and you say to your garage, Leviathan, sorry. If you want to learn how to build great web APIs, then stay tuned. Hey guys, and welcome back to this new episode. Let's take a quick recap what we learned in the last video. So in the last video we've talked about creating middlewares. We created a separate file for our middleware configuration, which we've imported over here. It looks pretty similar, except that we are registering middlewares here and no routes. We defined a little security function which was able to take a already hard-coded or predefined token and compare that to a specified token by the user, like in the URL as a get parameter. If this token wasn't provided, then we returned with a custom function or a custom response, which took the 403 status code HTTP, and we wrote something to the response stream. If this token has been provided, we also checked if this matches our already predefined or hard-coded token. In the next step, if everything went okay, we returned the usual response, which went up the normal middleware chain. We also talked about the importance of the order of definition. That means when you're specifying a middleware, then the first middleware is the inner ring, so to say, and if you specify another middleware, then it gets wrapped around that, and it's basically what you see in the background. So if a request comes in, then the second middleware actually acts first, and the first middleware actually acts second. And the last key was that you can actually add a middleware or multiple middlewares to either specific route groups or even specific routes themselves by just calling the add function. Next to adding middlewares globally. So in today's video we will talk about a very important concept of programming called dependency injection. We will see how this works in a Slim application and how we can use it to improve our applications. But first, let's talk about the dependency injection principle or concept in general before we start with Slim. To make it as short and easy as possible, you can imagine dependency injection like something like a garage. So imagine you can talk to your garage where your tools are stored. You put in tools which you need later. So, and you are doing your garden and you say to your garage, Leviathan, sorry, you can ask your garage for like a digging tool. So, hey garage, give me that digging tool, and the garage knows where it is and it provides it to you. So this is basically dependency injection. You are asking a container to provide a specific tool for you. This concept comes often with another concept called inversion of control, which means if you are like creating class A and class A is dependent on class B or an instance of class B, you're not likely to instantiate this class B inside your class A, because then it would be tightly coupled and you want to avoid that as often as possible. So basically class A says to the container, hey, I need this instance B or an interface of this instance B, and the container will provide it for you. Why, you may ask now? Well, because using dependency injection in this way can actually help you create multiple containers. For example, if you're doing like functional or unit tests, you can use a different container than you would use on your production or your staging environment. And this helps you by testing, maintaining your code, etc. Basically, this means things are more exchangeable and thus more flexible. Now let's jump right into the code and see how it looks in Slim applications. As our project grew in the last episode, I will create a new one this time. For this, I created a new folder called Slim.di project, and now I will install Slim as usual. For this, I will open a new terminal and call the provided installing function inside Composer, which I got from the homepage of Slim, which is basically this. As I executed this installing script, I got a very well-known error, so we will handle this now, if you encounter it too. To fix this error, just enter php-ini, which shows the loaded configuration file for PHP. Hold Control and click this one, and now you will see a basic list of configuration thingies inside the ini file. To make this work, but keep in mind we only do this now for the development environment, we will comment out this open base dir configuration thingy here. Now you can try to rerun this previous installation script and it will most likely work, but there's another error we get right now, so let's fix that too. We open up our PHP thingy again, which disappeared from my list here, don't know why. So just call it again, open this configuration file, and now we will do something too called disable functions. So basic functions like putenv, getenv and more are disabled for security reasons, but as this is only our development environment, I personally see no problem here, so I will execute that. And now hopefully this installation will succeed. Currently, it seems like it will work, and it worked, yay! In the next step, we will install a custom HTTP implementation, which is the implementation from Slim for the HTTP messaging standard. So I copied this command as well from Slim homepage, so I will execute it as well. And now we got this ready as well. In the next step, we will start setting up our basic Slim application. So we will create a new folder called public, which you know from the last episode or the previous episodes. We will create our index.php file, which does some basic stuff in a second if I don't make these stupid writing mistakes. And in the next step, we will also create a config folder where we will get to in a second. So as I would not like to bother you with typing everything by hand, I'll just take this copy from our last project, which is basically an import for our app factory. Then we will load everything Composer provides to us, so we have every class ready we need. And then we will use that factory to create our app instance. And in the next step, we will include two different files, or in a few seconds, for this case only one I think, and at the last step we will run our app. To set up the dependency injection, we will use a little framework called PHP-DI, which stands obviously for PHP Dependency Injection. You can see the documentation in the background over here, php-di.org, and then go to doc, frameworks, Slim. This is a specific integration for our Slim application. So go ahead and copy this line over here, head back to your terminal and execute this command, which will install the Slim bridge, which is some kind of adapter around Slim and PHP-DI. Let's see what error we got over here. Fixing that error is pretty easy. Just go to your Composer JSON and choose 4.2 as requirement for your app. Then go ahead and do a Composer update. If that is finished, you can repeat this installation command for PHP-DI Slim Bridge and everything should work fine. In PHP-DI's documentation, we can also see how we should then instantiate our app. So go ahead and copy this line. Back to our Visual Studio Code, we can now delete this import over here, just require that autoload and then create the app like suggested by PHP-DI bridge. Next, we should pass our configured DI container to the create method. So we will go ahead and use it like this, and we will return the container configuration from our config file, which we have not created yet, but we will still write it now. So go ahead and copy this path over here, as we just need to adjust it. So require dir inside the config folder, and we are going to require the dependencies.php, which we will create now. And if this is finished, you can pass this container to the create function. To see how we can configure such a container, we are looking at the documentation again and click this link. And now we can see how to configure such a container. So let's go ahead and create that dependencies.php file. Dependencies.php. There it is. Now do the basic PHP stuff. And now we can get started defining our container. The first step for our container will be to create a container builder. This thing is basically, as the name suggests, responsible for creating our final container. So go ahead into your dependencies.php file and create that new container builder instance. And the next thing we will definitely need to do is calling that build function which the builder is made for. So we call builder build, then we have our container, and we can return that container as the index PHP relies on the return value of our file. To start registering different dependencies, we can go to the PHP documentation, DI documentation again, which will have this little Autowiring hyperlink here. You can open this, then you will get here, and we will focus on PHP definitions. So to actually start adding different definitions, copy this line over there and put it here. We can now register different dependencies by using just some sort of associative array. That means on the left side there's the key, which could be, for example, test, and if a dependency called test is requested, this will resolve to what's basically over here. So we will just create one basic example. Let's create another folder called like services, and then we will create a new service called email service.php. Then we will do the normal PHP stuff, means creating that opening tag, specifying a namespace like app, and then services or service as your conventions tell you. And then we will do some sort of little class called email service, which is just the one we defined below. Then we will create a basic constructor, so public function or just function construct, both will work. And we have our little first service. Now we can say like public function, goddamn, send mail. And yeah, that's basically it. We won't fill it like for any implementation or so. We will just leave it like this to actually be able to insert this email service, or better said, inject. To have this email service injected anywhere, we need to add a new definition to our dependencies. And this is basically done like this. We can use like app service and then email service. And we can use this nice feature of PHP, which is basically a double colon, I think it's in English, and class, which basically translates to this whole path as a string. So this makes us a lot easier to use this definition. And now we can say, and this is basically what those definitions are for, each time when an email service is requested by anything, then resolve it to this. To make it a bit easier, we can use an already defined function which will help us create such as a quick way of creating such objects, which we will use now. So we can say use function from the DI namespace called create, and then we can use this create function for our email service class. Right now, this isn't really exchangeable or nice at all, because we are basically hard coding this dependency again. What we want to do is say, okay, if an interface, an email service interface is requested, then resolve it to this email service class. And when we are doing like unit tests, we could say, okay, if this email interface or email service interface is requested, resolve it to another concrete class. So to make this actually work, we will now define a service interface, which is the basic skeleton for each service which implements this interface. So we will create a new interface called email service interface.php. We will do the normal stuff like setting the namespace app service, and we will say interface. This interface is called email service interface, and we will specify a specific function. This email service interface needs to provide, or better said, the implementing class which implements this interface need to provide this function. So let's finish this by public function send mail, and now our email service can actually implement this. So we can say implements email service interface. We will use auto-completion, so I press enter, and as we are in the same namespace, we don't need to import this interface. And now we have an email service which matches this interface. And in total, this will make our dependency now exchangeable, as we don't rely on a specific class. I mean, after this definition we do, but so to say, as we are here saying, okay, each time an interface from the type of email service is requested, resolve it to this one. And I will explain more on this in a second. But wait, before we continue, I would really appreciate it if you like and enjoy my content. Then please leave a like, click that subscribe button and activate this bell. Okay, let's continue. So let's step away from the code for a few seconds. So imagine you are a developer for a company, and this company can provide some credentials to you which uses real production server services like this email one. So the problem about that is when you are testing something else, you don't want to like every time send a real email on the real or with the real credentials, because the problem which can occur there is that you go into limits or like request quotas. So if you have like a customer registration service which is responsible for sending out like emails, hey, glad you joined, blah blah, you know this crap. So the problem is, if you hard code the dependency of this customer registration service to like an email service, the class itself, then you have this hard-coded dependency which you can swap out. So you would always need to use the real production email service. But the key here is to make it like exchangeable, that on a local development machine you could use a mock, so to say a test implementation or a fake implementation of this service. So when the customer service is created and your email service is injected, this injected service is not the real production one, but an exchanged one which doesn't really touch the live API. And to provide this flexibility, you need to rely on abstractions and not implementations. And an implementation could be like Yahoo email service with specified credentials, or Amazon AWS email service or something like this. This is a concrete implementation, but the abstraction for that could be email service interface, and you will mostly like to rely on that and not on specific ones. And this is exactly what we are doing over here, because we are not relying on a specific implementation, we are relying on an interface, and that makes us possible to actually create some more definitions, like especially loaded from a dev file which is only loaded in dev environment, or a file which is only loaded in the staging environment. We can swap out those things by just adding another definition, replacing the old definition. So now we can say, okay, for the start it was this, but in the local development environment we will also say, okay, if some component requests this dependency, then instead of this here, resolve it to another one. So before we get any farther, let's start to restructure or reorganize our app a little bit. In previous episodes, I didn't want to confuse you by saying like, this goes here, this goes there. I just wanted you to focus on the basic setup. But now we will actually switch out some things and restructure it. Keep in mind that based on our requirements, this structure can be different for later episodes or in future projects I will show you. So in the first step, we will create a bootstrap file, which is obviously for bootstrapping our app. So go ahead and create a new file inside the config folder and name it bootstrap.php. Do the normal PHP stuff above. And then we will extract some of the things defined in the index.php file out to our bootstrap file. So the bootstrap file is responsible for bootstrapping our app, and this means setting up everything and returning a ready to boot app. So this app run command will not reside here anymore. So we are just going to load this autoload file, load the dependencies. Maybe we'll change that in a few seconds as well, like the container, etc. And then we will create that app, loading the routes and returning that app, that bootable ready app. So in the next step, we are going to import that file over here and just run that app. Basically, the index.php file is the entry of our app, and from there everything goes up. So in the next step, we will require that file and we will surround it like this, and then we can say run what you've got from this file, and we just return the app, so the app will be ran. So yeah, that's pretty much it for the bootstrap thing. Then we will take a look at our dependencies, where I just copied container builder, I think, from the documentation, but keep in mind that we defined the object builder here and not container builder, so make sure that you change this one here so it's correct. Then we will change how we actually registered those routes and go away from those closure functions, as they are most likely not very clean. So we will separate out our routes in specific controllers or actions. And for example, we have this little example route here, like app get on the root path, and then we imported that home controller, which resides in app controller, and I'll get to that in a second. So we are basically using an array here, which the first argument which is passed is the class itself, where a specific function resides, and then the index function, which is responsible for sending the response at this path. To make this work, create a folder called source src. Inside that folder, create another folder called controller, and there is our home controller. Let's look into this. So what we are basically doing here is we are specifying a specific controller for a specific route, or at least multiple routes, just like you wish to do. There are different ways, but the most cases you can prefer this one. So we are creating a final class which should not be inherited from, so this is a final class, and we have some other things. But first let's look into that index function which we defined in the routes file. So we will take a look at this first. The index function basically takes a request and the response. We are calling our email service here just for an example. That's not much to do here, or nothing really happening here. So, and in the next step, we are returning that response because every path should return a response. As we defined our email service interface inside the dependencies, we can now let PHP-DI inject this service into our controller. And we are doing this by using the constructor injection, which basically injects the service while creating that home controller. So on creating that home controller, our email service gets injected so we can use it later in the index function. PHP-DI could also inject those services into this index method, for example, as well, but I would encourage you to mostly use the constructor injection because it's, in my opinion, one of the most cleanest ways. For example, if you have like 7 different route paths or methods like index, and you repeat like 5 times that you need the email service, for me it's much cleaner to do so in the constructor injection and once, not like for 7 functions. But this depends on your use case. But I think it's also nice to know that you can do it like this too. Then I created this service folder and put our existing services into there. Make sure that the namespace fits your folder structure. And in the last step of our restructuring, reorganizing, you need to open composer.json, create this new autoload key PSR4, which is a PHP standard. So if you want to know more about that, you should look it up or watch my later videos. And we will basically map everything under the app namespace, which resides in that source folder. So everything maps correctly. One last tip. Use composer dump autoload or composer dump dash autoload to actually output your autoload file again, because we changed some configuration considering composer. In the next step, I want to show you some kind of dependency magic provided for us by PHP-DI. So as you can see in the background, I defined a service called test service, which basically has no contents, but this is the problem because it's just for displaying purposes. So I defined it in the correct namespace called app service, and I want PHP-DI to now inject this inside our index method or even in the constructor. For this, I just put it here as a parameter. So basically we could use it, but will PHP-DI be able to insert it? Because I didn't specify any definition here. How does that work? First, let's check if this works at all. So I'm gonna refresh this browser site here, and yup, this 200 OK status comes back. This works because we have a nice feature in PHP-DI called Autowiring. That means basically, as you can read here, it's the ability of the container to automatically create and inject dependencies. So in order to achieve that, PHP-DI uses reflection to detect what parameters a constructor or anything similar needs. So if you want to read more about that, I'll post the link of Autowiring in the description. So in today's video, you learned how to set up the Slim application in combination with PHP-DI to use this as a dependency injection framework. You have also learned some basics about DI in general, and that it comes often with something like IOC, which means inversion of control. This helps on building flexible and nice applications, which are actually nice to maintain and to test independently, for example with unit tests, etc. I'm glad you joined me on this episode today, and I hope I will see you in the next one. If you like my videos, please consider leaving a like, hitting that subscribe button and activating this bell. See you the next time. Bye bye.